Okay, so the next video is on intensity, and we're talking about the intensity of waves here. So we describe intensity as being the rate at which energy is transmitted per unit area. Now, rate of energy, energy over time, is given by power. And then per unit area perpendicular to the wave direction is simply just the area that it's been spread over. So if we look at like intensity coming from a point source here, it's actually going to be going radially, but I'm just going to use this as a little example here. As we can see as it's moving off, we can see that the intensity is being spread over a larger area. So we have an inverse relationship between intensity and area, and we can see that that intensity is getting smaller, over these different points. So we can start to use this to find out one of our relationships between intensity and the distance. And we actually have an inverse square law for this. So we say intensity is inversely proportional to the distance squared. If we have a look at that, if we go a distance of a defined value of x, and I take the area of which the intensity is covered over, I could say that that is just a. If I go then double the distance, so I go 2x, we then see that the distance the intensity is being, the area the intensity is being spread over is 4a, In this case, I've squared that distance. If I then go to a point of 3x over, my area that the intensity is being covered over, is 9 sets of the original a. So I've got 3 by 3 here. So in this case, we've got 3 squared. If I went to 4 times the distance, it's been spread over 4 squared, so 16 would be the area there. What that means is I'm essentially putting up here, I've got intensity over A. Here I've got intensity is equal to power over 4A. Here I've got intensity is equal to power over 9a. So each time we're just going down in terms of the intensity. So here I've just got my intensity is set at my defined area. Here it's going to be a quarter of the amount. So the intensity is being distributed over 4 times the area. Here we're going to 3 times the distance away, so I've got a 1/9 of the intensity. If I go to 4 times away, I've got a 16th. If I go to 5 times away, I've got a 25th of the intensity. So we call that an inverse square law. Inverse because it's decreasing, and it's decreasing by the square function. So again, sometimes when we're looking at that, we can sometimes link that to an inverse square graph. So again, we're looking at those, just seeing that our graph is decreasing as we go down. The other relationship that they sometimes like to ask, and they like this in multiple choice questions as well, is relating to the amplitude. And I don't know why, but the IB use A for amplitude for the intensity relationship, although they use it for x0 when we're doing the simple harmonic motion. So please be careful in your data booklets. Remember that this A stands for x0, so it stands for your amplitude. So we say that intensity is proportional to the amplitude squared, and you might be wondering where that comes from. But again, it comes back to that original equation of intensity is equal to power over area. So remember that power is energy divided by time, so power is proportional to energy. So therefore intensity is proportional to energy as well. Now using our energy equation for kinetic energy, we can say that it's equal to 1/2 m omega squared, and then the amplitude squared minus the displacement squared. I don't have that as a subscript, that should have been, there was a superscript. So in this case, looking at this, I could be looking at a particular point and I would have the amplitude. So kinetic energy is proportional to the amplitude squared. From this equation, we can see that. And since intensity is proportional to energy, intensity is also proportional to x0 squared. Just remember that this A here, this is x0, or x0 squared I should be using, because the IB just changed what they were using for their amplitudes there. I think it was also maybe to just not confuse you with this x up here, but there we go. And that's a little bit on it.